On February 28th, the breakup of Antarctica's Wilkins ice shelf into the ocean, which measured 406 square kilometers, made headlines around the world. This alarming discovery was made by Dr. Ted Scambos from satellite images. Dr. Scambos is the senior research scientist at the National Snow and Ice Data Center, or NSIDC, at the University of Colorado in the United States. Dr. Mark Serreze is also a senior research scientist at NSIDC and a Cooperative Institute for Research in Environmental Sciences, or CIRES, fellow. He's a member of the American Geophysical Union and the American Meteorological Society. Dr. Serreze has published numerous reports on his findings of the Arctic's shrinking sea ice cover. Currently, he is evaluating the causes for the decline in Arctic sea ice. On today's Planet Earth, Our Loving Home, Dr. Scambos and Serreze share their expertise in an interview with Supreme Master Television. Let's now hear from Dr. Serreze on his research in the area of glaciology, polar science, and what the implications of their discoveries of Arctic sea ice melt mean in terms of climate change.
My first question is, why is the Arctic sea ice so important to keep the ecological balance of the Earth?
If we think of the Arctic, we can think of it as the refrigerator of the Northern Hemisphere climate system. Now, of course, part of that refrigerator is because it's just located far to the north, so that the sun's rays don't strike it as directly as we would in the equatorial regions. But another big part of this is the existence of that sea ice cover itself. It's just reflective, so most of the sun's energy that hits that surface is bounced right back up into space again, keeps the Arctic cool. But now we're warming the system up. And what we're starting to do is lose that sea ice, that reflective sea ice. Okay, we're changing the nature of that Arctic refrigerator. The thing is that everything in the climate system is coupled together. Eventually, what happens in the Arctic influences what happens down here. And I'm talking, say, in middle latitudes like of the United States.
When you think of losing ice in the Arctic, what's the biggest impact?
When we think of losing Arctic ice, we can think of two components of ice. Right? One of them would be that ice which is locked up in the ice sheets, and we're talking here about Greenland. Right? Now, we start to melt down Greenland. That has impacts on sea level. There's strong evidence that that is, in fact, happening right now. Now, the other component of what we call the cryosphere in the Arctic is the sea ice. Right?
I see.
Now, the melt of the sea ice, loss of the sea ice itself, does not have an effect on sea level because that ice was already floating. Very different than Greenland. However, what we're talking about is loss of a very large area of a very white surface. This white surface, albedo is the reflectivity of a surface. Snow and ice, especially the sea ice, has a high albedo. We lose that sea ice cover, we reduce that albedo. We make that surface darker, absorbs more of the sun's energy. The Arctic heats up. But everything's connected. So if we change that Arctic sea ice cover, we change these patterns of heating. The atmospheric circulation responds to changes in heating. So the argument is you lose that sea ice cover, you start to impact things like patterns of weather, patterns of precipitation outside of the Arctic. We think of the Arctic sometimes as this faraway place, and what happens there doesn't matter. What we're starting to learn is that it indeed does matter.
This is where they talk about feedback and that type of thing, where it just go in a circle and then like a downward spiral.
Exactly. This is the whole concept of feedbacks. Even our earliest climate model simulations had been telling us that as we start to increase greenhouse gas concentration, it's the Arctic where we're going to see the changes first, and it's the Arctic where those changes are going to be the most pronounced. And a large part of that sensitivity is due to these feedback processes. The idea that once you hit the system with something, the effects of it start to snowball. Right. And the most important feedback in the Arctic is associated with this changing albedo, especially associated with this ice cover. Right. We warm up the climate a little bit by putting atmospheric greenhouse gases in it. We melt some of this highly reflective snow and ice cover. That means more of the sun's energy is absorbed. The Arctic becomes warmer as a result. That means more of the snow and ice cover melt. The Arctic becomes even warmer. So it's a feedback, what we call it, a process that feeds on itself.
The dramatic changes in the Arctic sea ice melts is a definite sign of the acceleration of global warming. Dr. Ted Scambos will further explain on other changes found in ice shelves of the polar regions when Planet Earth, Our Loving Home returns. Please stay tuned to Supreme Master Television.
This is a story about the living reef, the oldest city on Earth. These wondrous, complex communities are the most diverse places on the planet and are so important that the ocean cannot exist without them. And we cannot exist without the oceans. Unfortunately, pollution and overfishing are destroying the world's coral reefs. We've already lost 25%, and the rest may perish within a generation, unless we act now. Protect the living reef, and we protect the ocean. Protect the ocean, and we protect ourselves.
Welcome back to Planet Earth, Our Loving Home, as we continue exploring the polar regions and the vital role Arctic sea ice plays in maintaining the balance of our ecosphere. Dr. Ted Scambos specializes in studying the glaciers of Antarctica. He was first to discover the collapse of the Wilkins ice shelf in Antarctica via satellite images and lead a team of international scientists to study the region. Dr. Scambos was a contributor of the report Climate Change 2007, the physical science basis for the UN's Nobel Peace Prize winning Intergovernmental Panel on Climate Change, or IPCC. He shares his knowledge on the significant role of ice in the polar regions here on Supreme Master Television.
The only other component that's slightly different is the ozone hole in Antarctica, which is also caused by human activity. But the main event in the 2002, I think, really was a turning point. It's an icon image for saying that the Earth is changing because of warming. The blue patch of ice crumbling away, streaming across the ocean. That's become an iconic image that's been used hundreds of times by newspapers, books, magazine articles.
There have been broke up ice shelves that are much larger than that still in the past, in 1955 or something, I thought.
In 1955, there was an iceberg that was sighted that was supposedly larger than the largest iceberg that's been mapped to date. I looked at that newspaper story, and I've looked at some of the ice shelves. That's normal, and Antarctica has been behaving that way for millions of years. What's not normal is to see melt ponds on the surface, no sea ice in front of the ice shelf edge, and this sudden breakup, not just in one big piece, but crumbling, disintegrating, absolutely blowing itself up within just a few weeks. The other thing is that the ice shelf doesn't recover from it. There's no regrowth. There's no new shelf that starts to push out in the aftermath of one of these events.
You see any immediate threat to the ice shelf now? You look at A have fallen off, right? B already fall off recently. Are we watching C?
Yes, and there is a C, and there are plans to visit it as part of the International Polar Year. There's two major efforts, one from Great Britain and a joint effort between Chile and the U.S. to visit Larsen C and set up measurements so that we know what it was like before it really began to retreat due to global warming. We thought the only way that you would lose an ice shelf as part of global warming, but the only way you'd lose it is through this very slow process of calving and surface melting. You would have to wait for the warmth to reach the point where from the bottom, melting by the ocean, and from the top, melting by the air, that both of those things would conspire to thin the ice shelf to zero. What we didn't anticipate was that there was this runaway process of fracturing that happens. Once you get the top soaked with water, the water actually acts to blow the ice shelf apart. Not by frost heat. This is something that people in the north are familiar with, where rocks can be split open by a film of water that gets into the crack. It's not quite the same process. Okay. If you get a tall column of water, there's quite a bit of pressure at the bottom of it. And since ice is less dense than water, ice floats on water, the ice doesn't have that same level of pressure. It's not as dense, and so at the bottom of a crevasse that begins to fill with water because there's melt water on the surface. At the bottom of that crevasse, you get to a point where the pressure is so high that just the weight of the heavy water inside the lighter ice is enough to crack through the ice and drive it all the way to the bottom. It was something that had been talked about for some glaciers, but it had never been, nobody ever thought that it could happen on such a large scale so suddenly on an ice shelf. Right now, that's still the best model. There are some other things people have talked about, how the oceans are getting warmer, thinning the ice from underneath, how the ice shelf, because it was thinning, was starting to lose contact with the coastline, starting to break away from the coast. But in terms of what happened in March of 2002 and earlier in 1995 for the Larsen A, that had to do with water fracturing the ice very suddenly on one hot summer. And so if we got one really hot summer, between now and 2020, we could see the Larsen C do the very same thing.
Join us again next Wednesday on Planet Earth, Our Loving Home, as we continue our interview with Drs. Ted Scambos and Mark Serreze. Up next is enlightening entertainment right after noteworthy news, here on Supreme Master Television. May the grace of the Most High bring divine love and boundless blessings into your life.